In this video, we are going to learn how to solve absolute value inequalities. We'll start with this first example at the top left. What is the solution of absolute value of x is less than 5? Graph the solution. We're going to start by graphing the solution. We're going to look at our number line and see which x values we can plug in to the inequality. Now, obviously, if we plugged in 0, absolute value of 0 is 0, which is less than 5. So we know for sure that 0 will be in the inequality. 1 is also less than 5. 2 is less than 5. 3 is less than 5. 4 is less than 5. But 5 is not quite less than 5 because it's equal to 5. So we cannot include 5. But everything up to 5, for example, 4.9, would also be less than 5. Now, as I go the opposite direction, when I plug in negative 1, the absolute value of negative 1 is positive 1, which means that 1 would be less than 5. Then this negative 2 become a positive 2, and so on and so forth. And we get to the same situation, negative 5. When we take its absolute value, we get 5, and that is not less than 5. But, for example, we can also say that even negative 4.9, plugging that in would give us 4.9 is less than 5. So we have a kind of range of answers that we can use. And it's everything between negative 5 and 5. So to write this as an inequality, we'll say that negative 5 is less than x, which is less than 5, which normally read can also just mean x is between negative 5 and 5. This is referred to as a compound inequality. Now, let's look at the next example. What is the solution of the absolute value of 2x minus 1 is less than 5? Now, this just means that 2x minus 1, just like before, x was between negative 5 and 5. Now 2x minus 1 would be between negative 5 and 5. So as we write our compound inequality, we'll have negative 5 is less than 2x minus 1, which is less than 5. And we can go ahead and solve this inequality for x by adding 1 to each side of the inequalities. So it's adding 1 everywhere, making it negative 4 is less than 2x, which would be less than 6. And then to get x by itself, we could divide everything by 2, giving us negative 2 is less than x, which is less than 3. Give us the compound inequality, negative 2 is less than x, which is less than 3, which means that if I were to draw this on a number line, it would be all the solutions between negative 2 and 3. But then again, we're not going to be equaling those endpoints as there's no equal bars underneath the inequalities. So just everything in between. Which I imagine the 0 would also include the negative 1, the 0, the 1, and the 2. All of those numbers are included. Now, what is the solution of absolute value of x is greater than or equal to 6, with the emphasis being on greater than? Now, certainly 0 cannot be plugged into this one. Neither can 1 or 2 or 3 or 4 or 5. But now that we have this equal to, 6 could be a solution. But not anything less than 6. And as we plugged in 7, that would be greater than 6. And so same thing with 8, 9, 10, 11, and so on. And all of those become solutions, that entire range up there. And you'll also see, as I go left, negative 1, when I take its absolute value, becomes positive 1, but it's still not greater than 6. And I'll keep going down my number line until I hit negative 6, and I'll see that when I take its absolute value, it becomes positive 6, which is equal to positive 6. And negative 7 would become positive 7, which is greater than 6. And everything to the left of negative 6 would also be included because we take its absolute value. So now we're not getting a range that's in between two numbers, but rather greater than 1 and less than another one. But since you can't get a number that exists in both those groups at the same time, we're going to use a compound inequality involving the word or, which could be technically both at the same time, but typically is either in one group or the other group. So we'll see here we have x is going to be less than or equal to -6, that equal to being there because it can be -6, or x is greater than or equal to +6. This is another version of the compound inequality. Now take that logic into a slightly more in-depth answer. It's more multi-step. We'll see that absolute value of 2x plus 4 is greater than or equal to 6. So now I can look at this question in this sense, that 2x plus 4 is less than or equal to -6. Or it's going to be greater than or equal to 6. Forgot to put the equal to in my red note, but please keep in mind that since it is equal to here, it will be equal to throughout the rest of the problem. And I can solve both of these inequalities by subtracting 4 and then dividing by 2. Leaving with a compound inequality, s is less than or equal to -5, or x is greater than or equal to 1. So when I go to graph this, I'm going to put a little tag near -5 and a tag at 1. 0 would exist somewhere around here if you want to have a reference point. And I notice now everything that is less than or equal to -5, so a filled in circle for equal to, and then everything that's less than that number on the number line. And everything that's greater than or equal to 1, so closed circle on 1 to say we include 1 as an answer, and then everything greater than that, meaning 0 is not a solution. And just like with last lesson, you can take any number that's within that range, plug it into the inequality just to check that you are correct.